Good afternoon, everybody, and welcome to this very special live Q&A with us, where today we are talking all about sleep and body clocks. So if you've ever wondered why you don't get a great night's sleep after looking at your phone for a long time before bed, or why our bodies get so confused when we go to different time zones, then you're in the right place. We are live, so if you have questions, then do pop them in the chat. I will be keeping an eye on that. And we've also got a few questions that we've had in advance on social media, so we'll be going through those as well. So today I'm delighted to be joined by Dr. Manuel Spitzchen and Colleen Wienzepflen. Manuel is a researcher in the Department of Experimental Psychology here at the University of Oxford, and Colleen is not only a neuroscientist, but also an illustrator. And the two of them have been involved in putting together an amazing comic book, which is all about sleep and body clocks. And the link for that is in the description below the video. So I'd encourage you after this to go and check that out because it's fantastic. And one of the great things about this live Q&A is that in addition to talking, Colleen is also going to be drawing along. So as we discuss the answers, she's going to be putting some cartoons and comic book characters into the feed. So I'm excited to see what she's going to be drawing for us. So without further ado, we've only got half an hour, so I shan't talk much more. I will let Manuel and Colleen introduce themselves. Manuel, nice to see you today.
Thank you, Fiona, for the introduction. I'm very pleased to be here. Very good to see the audience as well and see there's interest in our comic book. Maybe a little bit about myself. I'm, as Fiona said in the introduction, I'm based here in Oxford. I am a psychologist by training. And one of the interesting things about psychology is that it's a very broad field, and I got started in it by in various research projects looking at visual function and visual perception. So how do we see the world? From that, I kind of veered into understanding the function of a specific aspect that light controls in our bodies, and that is the circadian clock, and we'll come to that in a second. And most recently, of course, we've been working on this comic book. I'm very pleased to be here today and looking forward to answering the questions.
Brilliant. And Colleen, do you want to just quickly introduce yourself as well?
Mm-hmm. So hi everyone, I'm Colleen. I'm the author and illustrator of Enlighten Your Clock, the comic book. I just finished my studies in neuroscience, cellular neuroscience in the University of Strasbourg in France. And I was introduced to the chronobiology during my bachelor degree in biology, and I really liked it. So I wanted to do an internship in this field. So I go with Manuel in his team. And yeah, we have the idea of creating a comic book about it, about the science of sleep and chronobiology.
Fantastic. I think we'll be asking you a little bit more about the comic book a little bit later on and how that came about. But I'm sure people are eager to have some of these sleep questions answered. I should say, just as a bit of a disclaimer, obviously, if you have concerns about your sleep and your sleep health, and then do talk to a GP. We're just here to talk in general about sleep research. But if you have any concerns, then of course, they should be checked by a medical professional. So I'm just going to start right back at the beginning. You might have heard the phrase circadian rhythm, but not know exactly what it means. So I think that would be a good place to start. Manuel, would you be able to tell us exactly what a circadian rhythm is?
Absolutely. So what's really interesting about almost all functions of our bodies and our brains is that they are organized in a 24-hour fashion. And in chronobiology, we call this the circadian rhythm. And circadian is really a word that consists of two words. It's got circa and it's got dian in it. And so circa is, approximately, it means approximately. Dian means day. So it's an approximately daily rhythm. And what this means is there are many different processes in our brains and our bodies that have some variation at the scale of 24 hours. So something might go up and down within a 24-hour window, and there's numerous things that we know through experimental studies that are like this. So one prominent example that we know about from laboratory studies a lot is, for example, the change of performance as a function of time of day, but also as a function of the biological rhythm that we have. So, for example, if I was asking you to remember a bunch of words and I asked you later on, can you recall these words, your performance will vary depending on what time of day I'm asking you to do this. And generally in chronobiology, there's a distinction between what we call diurnal, so it's changing at the 24-hour cycle of the day, so as a function of time of day, versus something that's changing as a function of our body clock. And it's really important to realize that some things change diurnally, just because, for example, the sun is setting, the sun is rising, but there's also an internal process or internal processes in our brains that are that represent this 24-hour scale. And so this includes, again, cognitive performance, this includes the production of certain hormones, this includes body temperature. So for example, our core body temperature is at a minimum at night, independent of whether we sleep or not. And there's all kinds of examples like this, all kinds of physiological signals that vary across this 24-hour time scale.
Brilliant, thanks. I think most people will be familiar with the fact that they'll feel more switched on at certain times of the day than others. So how is this whole system sensitive to light then? Because I think that, yeah, that's something that you're particularly focused on.
Right, so I think this is a really, really interesting question. I think light has, I think in the past couple of years, become really prominent in thinking about how should we organize our light exposures and what kinds of light should we avoid, for example, in the evening. And it turns out that the circadian system is very sensitive to the timing of light and light exposure. And so if you're thinking back about the physiological rhythms that we have, what we can do with light in specific experimental situations, so in the laboratory, is we can change the timing of the circadian rhythm. And so we can move it forward, we can advance it, as we say, or we can move it later, so we can delay it. And that's a really interesting phenomenon, basically light exerting this function of entraining us to, as it were, the 24-hour cycle. And this is a function of a connection that goes from the eye, the eyes, of course, that we see with, to a structure in the brain that's called the hypothalamus. And the hypothalamus is a relatively small structure, but it's relatively important in supporting various neural functions. And part of the hypothalamus is a structure called the suprachiasmatic nucleus, the SCN. And it's actually not... Sorry, say again.
Sorry, I was just saying that's a mouthful.
Exactly, yeah, the suprachiasmatic nucleus. It is supra, so it's above the optic chiasm, which is where the two optic nerves cross. That's why it's suprachiasmatic. We typically just call it SCN, and it's about the size of a grain of rice, but it holds effectively what we call the circadian clock. It is effectively the structure in the brain that is, as it were, the orchestrator of all rhythms or many rhythms in the body. And it gets activated by light exposure. So through the eye, there's a layer of cells in the eye that is light sensitive, then goes to the hypothalamus, the SCN, and basically tells the SCN, oh, it's now day, or it is now biological day, or it is biological night. And from there on, there's various things that the SCN then projects to as well in the brain, and working then on, for example, the production of hormones and modulating cognitive performance, for example.
Brilliant. I'm enjoying watching Colleen draw it as well. There's a lovely hypothalamus there linked to an eye. In fact, now might be a good point. We had a question in on social media, maybe not a scientific question. I think it was from Aki, who was wondering what the girl's name and what's the cat's name is. I don't know if, Colleen, you've come up with names.
I didn't find a name for the girl. If you have one, you can always tell me and we will name her. The cat doesn't have a name either. Yeah, sorry.
Needs to be a competition then. One of the people watching, send in a name, and we can name the cat and the girl, because I think they could do otherwise. Fantastic. So yeah, just to go back to what you were talking about then, Manuel, are there different types of light that we're sensitive to? Presumably sunshine has a bit of a different effect than, for example, a laptop screen or something like that.
Yeah, so it all boils down to the light sensitive cells in the eyes that are responsible for signaling whether it's day or night. And this is really something that I think as a scientist is really exciting, because we've only known for about 20 to 25 years that there are cells in the back of the eye that are responsible for setting the circadian clock. So I think from biology, and I think many of us might be familiar with these terms, we know that there's the cones in the eye and the rods. And these are really the photoreceptors. They're light-sensitive elements that allow us to see during the day and during dim lighting conditions. They enable us to see in color. And if you're watching this stream or this session, your cones will be active in encoding the color of the screen and little windows, etc. In addition to the cones and rods, about 25 years ago, researchers discovered that there's another class of photoreceptors, another class of light-sensitive cells called and this is again another mouthful, the intrinsically photosensitive retinal ganglion cells. We abbreviate them as iPRGCs. What's really interesting about them is that they are sensitive to short wavelength or blue light. They are most sensitive to light at a wavelength around 490 nanometers. So this corresponds to kind of a maybe cyan blue. And effectively, when they're activated, that they will then send signals to the SCN to say, well, we're activated, and that, of course, then in the brain will trigger various other responses. And so then coming back to the question, well, what kinds of lights is the circadian system sensitive to? We really have to look at the sensitivity of these cells to understand this. And of course, then, wavelength is one aspect of it. But it turns out that these photoreceptors don't just like one wavelength, they like all kinds of wavelengths. They just preferentially like one wavelength more than the others. But the consequence of this is that any light, if it's bright enough, will activate the iPRGCs. And so, for example, daylight has what we call a relatively broad spectrum. It has light at many different wavelengths. And so it'll activate the iPRGCs more efficiently, as it were, than, for example, LED lighting or other lights. And of course, if you are looking at a bright screen at night, for example, that will also activate the iPRGCs. So it's really, there's I think two components here. One is we have a dependency on wavelength and the color of the light. But then ultimately, if a light is bright enough, it'll just activate the iPRGCs. So I think this is kind of the key question, or a key aspect of this is that, the color of the light is secondary in a way. I think generally we think about these effects to be very much intensity dependent.
Interesting. So I suppose this very much comes down to the point of looking at screens before bed, because quite often you hear that, don't you? That, you shouldn't scroll through your mobile just before you go to sleep or before you go to bed, because it obviously activates that part of the brain. Is there something that people can do? Again, you were just talking about colors, and sometimes you get these apps, don't you, which let yourself set a phone to be more red or more blue. Is that something that you would recommend, or?
I think this is a really interesting question, and one question that I think we get a lot. And I think, so of course, there's kind of various components to it, right? So we know that there is this short wavelength sensitive pathway in the brain. And I think we have plenty of evidence that this pathway exists, and we know that it has the effect on the circadian clock. The other aspect of this is, how do these studies that we have, in the laboratory where the conditions are very well controlled, how does that translate to real world situations? And the real world situations that we're typically in is, of course, we're exposed to smartphones, but you're also exposed to room light, right? And we know that, for example, room light also can have an effect on the circadian clock. I think generally, and so this is, I think, one aspect, which is, I think the science is pretty robust, that we know there's a pathway, we know that it translates to some degree to the real world. I think the other aspect of this is, so of course you can tune your lighting you can tune the color of your smartphone screen. You can make it a little bit more orange. You can remove these short wavelength components. What is much more effective than doing that is actually just dimming the screen. And so if you take a smartphone and you just put it to the lowest intensity possible, I think that might be more advisable than playing with the color tuning, because if you change the color but keep the brightness of the screen the same, and it's just a different color, there's not a lot of change you can make by just changing the color. And so generally then we're saying, well, if you are concerned about this, dimming is a much better strategy in a way.
Yeah,
there's another component.
It makes total sense. Thinking about what you were just talking about in terms of it being intensity. So yeah, dimming is better than changing the color.
I think there is another component to it, which I think as chronobiologists, I think I don't think we have a good handle on this, which is, of course, there's a reason for why you're using a smartphone late at night, right? It's because there's interesting content, or you want to be in touch with your friends, or you want to read the news. There's something that keeps you activated in some way, right? Yeah. So there's a psychological reason almost to say, well, I want to be connected to the phone. And of course, we can change our light, however long we want, if we are nonetheless activated in some way by the content of what we're looking at on our smartphone. Then no change of lighting, I think, would undo these effects, perhaps. And of course, then I think there's a component also of preference, right? So even if we think that changing the color of the screen is not the most effective thing to do, because we can always dim it or just turn the light off or not use it. I think there's another psychological component, which is, well, I certainly like the warmth of an orange screen in the evening more than a kind of clinical white smartphone screen.
Yeah, I think a lot of people would agree with you there, and the same with, as you were saying, the light in the room. So some people might prefer to have a nice warm light in the evenings, nice and cozy. But I think what you were saying about the content is also, of course, a very important point, that if you're engaging with a very stimulating piece of content, then it's not going to be the best conditions for having a very relaxing night's sleep. So that's really interesting. I'm just conscious of the time. I can't believe these things always fly by. Do keep your put your questions in the chat if you have questions to ask our scientists while we're on here. Otherwise, I will continue on with our pre-prepared questions. So I wanted to ask you about melatonin. I think a few people might have heard of melatonin, but not be exactly sure what it is or why it affects sleep. So perhaps you could give us a bit of information about that.
Yeah, so melatonin is a hormone that is produced naturally by the body. And what's really interesting is that it's generally not produced during the day, and about 1 to 3 hours before our habitual bedtime, so when we usually go to bed, it starts to rise. So the secretion starts and it starts to rise. The pathway, and so in addition to that rhythm, so this is another one of the circadian variations you have, even if you don't, so if you bring people to the lab and you keep them awake for 24 hours, you give them no opportunity to sleep, for example, you will see these variations in melatonin production. And it's quite robust. It kind of has a peak maybe 2 to 3 hours after your bedtime. It's quite a reliable, what we call a reliable biomarker of the circadian rhythm. We can isolate melatonin, the melatonin production, in the laboratory, where we have a technique that's called the dim light melatonin onset. And so what we do there is we bring people to the lab, we keep them in dim lighting, and we just measure melatonin concentrations through saliva or blood, for example. What's interesting, though, is that the production of melatonin is sensitive to light exposure. And just like the circadian clock is sensitive to light exposure, if you activate the IPRGCs, they will then signal to the hypothalamus, and that triggers another cascade, triggers another circuit that effectively suppresses the production of melatonin. And so if you're exposed to light before bed, then the production of melatonin will not be as high as if you were just in darkness or dim light. And of course, this is quite interesting. We use melatonin quite a lot to assess this pathway, this neural pathway that goes from the eye to the circadian clock, because it's relatively easy and straightforward to bring someone to the lab for a couple of hours and measure their melatonin through saliva and expose them to different kinds of lights.
Brilliant, and I'm enjoying seeing the graph of melatonin production that Colleen's put there. So the amount of light that we're exposed to during the day really does make a difference. It's not just the light just before bed; it's something that's continuing throughout the day, and that affects how we're feeling.
Yeah, so this is really interesting. So there's now kind of mounting evidence that says basically the type of light or the amount of light we're exposed to during the day will affect how sensitive we are to evening light, right? So if you are experiencing a very bright day, then you might be a little resilient to evening light exposure. So rather than, for example, trying to avoid looking at a smartphone late at night, you could imagine exposing yourself to more daytime light. And I think this is something that my team is quite interested in understanding a little bit further and trying to understand, well, what is it that causes this mechanism to adapt? What is it that makes our light sensitivity different if we are exposed to bright light during the day?
Yeah, absolutely. A really interesting part of research. We've had a question sent in from Yutang, and it's not related to sleep, but people might think of their skin when they think of melatonin. And the question that was asked is, does it increase risk of skin cancer the more you're exposed to light? Obviously, you want in this situation to have enough light that we are nice and awake, but equally it can be dangerous to be in the sun. So I don't know if you have a comment about that.
Yeah, 100%. I think it links in with this idea of, if I tell you, okay, you should expose yourself to more daylight during the day, naturally you will also expose yourself to more sunburn risk. I will say I'm not a skin cancer or sunburn expert, but what we know about these effects is that they are largely mediated by UV, so ultraviolet light. And it turns out the visual system is, so our eyes are not sensitive to, of course, they are sensitive to excessive UV light, but the effects on the circadian system are not mediated by the UV, right? So I think to balance the recommendation to expose yourself to a lot of daylight or sunlight, always make sure to wear sunscreen. I think these things are very important. But of course, there will be light sources. So if you're in a room and you have artificial illumination, then that's, of course, and you can make it as bright as possible, then generally that's not typically a risk, right? And also outdoor light exposure then that comes from windows, of course, will filter, depending on the windows, will filter a lot of the UV component as well. But yeah, I think it's, I guess the statement to say spend as much time outside to get sort of these resilient effects of light exposure during the day, I think we need to qualify that and say, yeah, make sure you don't get sunburned, because of course, radiation from the sun contains UV, and that is quite damaging to all kinds of tissue.
Absolutely, got to be sun safe. The person that Colleen has drawn does not look too happy. She looks pretty hot. Yeah, but that was a great question. Thank you very much. We've actually had a question just come in on the chat from Timaeus. He's asking, is there a difference in how the lights on Kindles affects our eyes and tablets? I presume because he's referring to that very matte paper kind of effect that you get on a Kindle.
That's a really good question. I'm not 100% sure, mostly because I haven't looked at how, so presumably Kindles I think are backlit, right? So they have probably some LED behind them to illuminate it. Yeah, I'm not 100% sure, but I would expect that, there's going to be an upper range of illuminances or an upper range of light levels that these tablets can produce. And I would probably expect that they're going to be lower than what you have in a smartphone. But I guess I'm going to say, so this is something that's easy to find out and easy to quantify if we can measure it. Unfortunately, I haven't done the measurements. So the way you would do this is you take the Kindle or you take whatever device you want to measure, you place it in front of what we call a spectrometer. And that's a device that can measure the spectrum that's emitted from a light source. So what is the energy at a given wavelength? And when we have the spectrum, we can then determine, well, what is the effect on the IPIGCs? What's the effect on the circadian sensitive light receptors? So in principle, it's easy to know if we had a device and we had a spectrometer. And of course, this is stuff that we have in the lab, but I think I'd have to make stuff up to give a confident answer here.
No, it's perfectly fine. And, there you go. There's an interesting piece of research yet to be done that has been sparked by our Q&A. So absolutely, we're still, I think it's fair to say this is an active area of research and we're finding out new things all the time. So yeah, it's always good to think about these questions. We've had another one come in from Hafiz. When it comes to melatonin, when during the day should you be exposed to light in order to best, he's put, immunize ourselves to evening light exposure? Is it best to get light in the morning, or does it not matter when during the day?
So that's, I think, really interesting. I think we have various data points that are relevant here. So for example, we know that exposure to morning light or exposure to light in the morning, our biological morning, will advance our circadian rhythm, which I think is generally thought to be a good thing. I will say, I think we probably don't have enough data that will tell us exactly for the protective effects of light against evening light exposure. I don't think we have a good data set that will speak to this. And I think part of the problem is that, and I think you have this a lot in this kind of research, is that if you're exposing people to light to change something about what you're trying to measure, you will have perturbed the system. And so, for example, if you're exposing someone to light, you might change the timing of the circadian system. In which case, if you want to then say, okay, how sensitive, or you want to measure how sensitive you are to evening light, you might be at a different time already because you've shifted the circadian rhythm, right? So you can't, in many cases, manipulate the system and observe it, as it were. I'm going to say, I think, sort of intuitively, I think the morning light exposure, I think, and because of the circadian phase advancing effects, I think that's important. But for example, if you asked me, well, is it better to go out at 12 o'clock or at 1 p.m.? I don't think we have good data that would speak to that. And it might also be not easy enough to measure this robustly. The other thing that I think we don't know, and I think this is quite important to realize, is, does it matter whether you're 50 minutes out during lunch or 45 minutes? Generally, we think the longer the better. But again, I think we're missing some data points there to really make evidence-based recommendations, apart from daylight exposure is good and morning light exposure advances. A lot of opportunities, I'd say, to collect more data and do really interesting research.
Absolutely. But yeah, great question, Hafiz. Thanks very much for sending that in. We've had another question, but I think I'm going to just leave that a little bit for before the end, because I think it'll be a nice way to wrap up. A few people here maybe might be familiar with having had to pull an all-nighter every now and then. In other words, not going to sleep at all overnight. Do you think that has any sort of long-term health implications if we were to do that too frequently? Is that something people should be concerned about?
I would recommend not doing it. I think, I think we've all, at least I certainly have done it in my career, and I think it's sort of, it takes you a couple of days on it. I think if you do it regularly, I think that might not be advisable. I would say, if you can avoid it, then try to avoid it. But of course, I think it all links to the beneficial effects of sleep, right? I think sleep has a really important function in clearing various chemicals, in supporting cognitive performance, in also synchronizing our circadian system, and I don't think I would recommend it. But of course, there are certain professions, for example, if you're a shift worker, or if you're a medical professional, healthcare professional, where you have really long shifts, for example, and I think these situations then that become part of, I guess, your occupational activity, right? And I think that's something to keep in mind, is that there will, in a given society, right, you will have people who are almost by guarantee in some weird circadian state, and I think this is something that, again, I think as scientists we have some ways of improving, for example, shift work schedules to make them more friendly. But I think that is just knowledge that I think it needs to be much more established, I think, in society. So just to answer your question, I think, don't try to get the work done during the day if you can, and if not, then make sure you get a lot of catch-up sleep.
as you say, aside from shift work, I think generally all-nighters are out of necessity. So if can be avoided, then all the better. So you did touch on just how important sleep is for a number of reasons for our overall well-being. Taking that into account, do you have any, this is quite a broad question, but any tips for how we can improve the quality of our sleep? I know that a lot of people will be interested in that.
I mean, I think there's some very, very simple things that one can do, and I think, yeah, I mean, I think there's some that are relatively easy to implement. I think the first one is, so I love drinking coffee, for example, and I drink a lot of coffee, and I think, not drinking coffee, I don't know, I think the window that people say is 8 hours before you're trying to go to bed, right? So make sure you get the last coffee in maybe at 3 or 4 p.m. or something like that, depending on when you want to go to bed. I think the other thing is, similarly, I think to coffee and these kinds of stimulants is nutrition, right? So you don't take, typically you should avoid going to bed with a full stomach, right? So don't take a large meal just before going to bed. Of course, there is I think coming back to the light, right? Try to avoid bright lights and bright light exposure before going to bed. And I think the final thing, and I think this is something that's really kind of sometimes hard because, I think there's various reasons why we're not going to bed or why we don't want to go to bed. But I think generally we think keeping a regular sleep-wake cycle is really important, right? So if you have kind of a routine, keeping a regular time to go to bed can then support sleep quality. I think something about, I think we have all of this listed in the comic book as well. We have, I think, sort of a nice page where we have various tips. I think listen to your body, right? If you feel sleepy at night, then I think this is something that you should listen to and not ignore effectively.
Absolutely. You just touched on routines there and when to eat and things like that. What about exercise? One of the questions that was asked before this session was, do you have a particular time you think it's good to do exercise, or is it more about putting it into a regular routine so it becomes, you always exercise before work or something like that?
I mean, I think this is kind of an interesting interesting question. I think it's quite important to realize that there is kind of an interaction, I think, between optimal timing for things and what we call the chronotype. So chronotype is kind of I guess what we call a trait. It's something that is kind of characterizes whether you're a night owl or basically an evening person or a morning person, an owl or a lark. And generally, I think, if I remember well, so I think there's various studies that have shown this. I think there's one interesting thing which actually shows that exercise itself acts on the circadian clock, right? So if you are exercising at the wrong time, it can shift your circadian clock. If I remember well, I think the data there is quite interesting. I'm gonna say, I guess my routine is to go running kind of in the late afternoon, early evening. But yeah, I think in terms of recommendations, I think it probably depends on the workout as well. So, and I'm not 100% sure I will be able to make a confident recommendation here. I'd have to look at the data for that actually.
No problem. We've had a number of questions in. People have suddenly enthusiastic with their questions, which is really great. Keep them coming. I know we haven't got too long, but I think that hopefully, Manuel, you might be happy if I tweet some answers afterwards if we don't get round to all of them. Brilliant. So just because it's kind of linked to routines and eating and all that kind of thing, regarding food, are there any particular types of food that we should avoid before we go into to sleep? For example, sugar. I guess maybe logical that you don't want to have a big sugar rush before you go to sleep, but do you have any particular research on that? I guess slightly outside of your field.
Yeah, again, I'd have to look at the most recent research. I mean, I think there's a concept that has kind of come up recently, which is this idea of time-restricted eating, right? So the idea that you kind of have a 12-hour window or an 8-hour window or something like that of eating, which I think generally, I think, puts your body in an interesting kind of state. I think, again, I'll have to look up exactly when is the best time to eat which nutrients, but I probably would agree with you that, I think a very carbohydrate heavy or sugar heavy meal before going to bed is probably not going to be conducive. It's probably a question of, one, is there good data on this, right? And so what's the quality of the data? And I'm not 100% sure I know the answer to this. I would probably, again, also have to research or do some literature searching here. But I think some answers are out there, so I'm happy to respond to any questions after the stream.
Thank you, that's great, and great question, Marcel. Thanks for sending that in. I think we'll just answer Joel's, who says, are there any good methods for resetting a messed up sleep schedule? Because the time zones, I haven't quite recovered a proper schedule since my semester ended. Do you have any tips and tricks of how somebody might get into a regular sleep schedule again?
I think to me, I think regularity is really important. So I'd say, having a routine of, getting up at the same time, going to bed at similar or the same time, I think would be quite helpful. I think exposing yourself to daylight, and in particular morning light, I think is quite important to set the circadian rhythm. And I think this can be, sometimes quite challenging when you're in places where, you have a lot of rain or a lot of dull weather. But I think this is going to be important, right? So having bright days, I think, and dark nights is to me, I think, the key. The other thing that I think is quite helpful as well is thinking about what makes you tired. And one of the things that can make you tired and can also impact this is exercise, right? So I'd say, and this falls into the category of, well, if you're going out in the morning for a walk, well, you could also turn it into a jog, and then you have two benefits, right? You exercise your body, and you have the light exposure, right, at the right time. The one trick, so this is a personal thing, and I think there's a little bit of research on this coming out of a lab in Colorado, is this idea of, what properties do camping or outdoors trips have? And I mean, my personal experience is that when I'm camping, and I'm just an outdoors person, I really enjoy going camping, I'm much more in tune, and I have a much more regular sleep-wake cycle than if I'm at home and I have, books and TV and my laptop and work emails and, WhatsApp and whatever, all kinds of interesting things that I can spend my evening with. Whereas, of course, if you're camping, then you might have a headlight if you want to read your book, but on days like, you'll wake up early, you wake with the sun, you go to bed when the sun sets. And I think that might be an easy but maybe short-term fix also to get a regular cycle back. In addition, of course, you have all the benefits of outdoor exposure. But I'd say, bright daylight, morning light, exercise, and routine and regularity, I think, are key.
Brilliant, thank you. And thanks, Joel, for your question. See, go camping. I think that's a great tip. Good excuse. You can say you've been advised to go. Get your sleep back on track. Brilliant. I'm aware that we have almost run out of time, unfortunately, but we've all been looking at Kilian's amazing drawings. I wonder if one of you, either Manuel or Kilian, could just tell us a little bit about the comic book that you've produced and how that came about. Kilian, do you want to?
Manuel, you want to speak?
I can take that. So I think one of the things as a scientist is that I find quite interesting is this question of how do we communicate the things that we do in the lab and the research findings that we can generate and that we could find based on what other people have done. How can we turn that into information that's useful for others who might not be scientists, or who might be scientists in a different field, or who might be interested in this? And this is kind of where the idea of the comic book came up, which is we wanted to kind of experiment. I'd say, I think to me at least, it was really an experiment to see how far can we take a science or evidence-based comic book? How can we break down complex scientific content and bring a little bit the complexities on a paper and understand a little bit what types of tricks we need to pull. For example, talk about specific retinal cells that have complicated acronyms and complicated abbreviations. And so when I learned that, so Colleen was interested in doing an internship with me, and I was involved in a consortium of researchers here in the UK looking at sleep and mental health in teenagers. And we thought, well, why don't we put these two things together and try to develop a resource that's accessible to teenagers, but also really anyone of any age who's interested in this, to bring these topics a little bit to life, tell a story, but also not dumb down, right? There is this kind of challenge of making things accessible without making them too simple. And I think this is really the background or the backdrop of how this comic book came about, which is, you know, we had scientific knowledge and scientific information that we really wanted to communicate. And I think Colleen has done an amazing job in putting this together.
I totally agree. And there's a comment in from Charlotte saying the drawings are amazing, and I completely agree. It's been watched, they're beautiful, and I would thoroughly recommend anybody who's tuning in now to go and check out the comic book afterwards, because it's brilliant, and the link is in the description. So I think we'll just wrap up actually with a question that Charlotte sent in, which is, I'm just scrolling back, what exciting research do you think will be done in the near future? I think that would be a nice place to finish. We've touched upon lots of things that are sort of on the horizon. What exciting things are coming up in sleep research?
So I think, at least to me, I think there's really two main strands of kind of importance. And I think the first one is really understanding how we can bring all of our lab-based tools and make them applicable in the real world. And so, of course, you know, one of the things that we can do in the lab is we can isolate specific things. We can lighting to have a specific power or specific wavelength, and all these things I don't think matter that much when we have real people in the real world where we can't control these things. And I think this is, to me, the biggest challenge in research is how do we do this? How do we translate findings from the lab to the real world without losing you know, the quality of the scientific evidence? And I think that's something that, you know, there's a lot of people who are working, I think, on this, and I think it's a major challenge, is going from the lab into the real world. And I think the other bit that I find quite interesting is this idea of, well, how do we make the findings that we generate in the lab, how do we make them applicable to a wide and general population of people? And so, for example, if the recommendation is to say, oh, you should all buy new light bulbs, you know, surely that can't be a solution, right? I think this is something that is important. I think a lot of problems in biology, I think, or a lot of problems in our physiology and our behavior, I don't think can be fixed by technology. I think they need to be fixed or addressed somehow by behavior. And I think this is, to me, a really exciting area of looking at this question is, you know, how do we get people to make the right decisions about their sleep, about their light exposure, and how can we support this? And I think this to me is really a key emerging research area as well.
Absolutely, really fascinating, and it will be exciting to see the developments that are made in the next few years. I'm sorry we have had a couple of questions that we haven't had time to answer, but what I'll do is I'll talk to Manuel and Colleen afterwards, and I'll put them in the comments of the YouTube feed. So all you have to do is come back here and we'll try our best to answer those. Manuel, Colleen, was there anything else you wanted to say just before we wrap up? No problem if not. I think you finished in quite a nice way, but don't want to cut you off just in case. Brilliant. Well, it's been a joy to see Colleen's drawings come to life. Thank you so much for doing those, and of course, hearing all of your fascinating insights into the world of sleep and body clocks. So thank you very much to you both, and thank you to everybody who's joined us. It was really lovely when we get questions coming in and we can make this nice and interactive. So yes, if you don't already, please do follow us on Facebook, Instagram and Twitter. We're at Oxford Sparks, and we've got lots of podcasts and videos for you to check out, live events like these, and it'd be really wonderful to have you as a follower. So brilliant. I think there's nothing left to say other than have a lovely afternoon and evening, and we hope that you'll be able to join us for an event soon. So thanks again to Manuel and to Colleen, and bye for now.
Bye-bye.